Yes. Okay. So let me start by sharing my screen. Share screen. Okay. Can you see my screen now?
Yep.
Okay, good. So today I wanted to make a small presentation about our work on continuous vulnerability scanning and more specifically to advisory ingestion, right? So it's more like a progress report, what we have been doing. And I'm also going to try to give you an advisory feeder demo. This can be more of an open discussion, right? And we can structure this around this small presentation. So let me get into it. So let me take a step back and explain what the bigger picture of what we're trying to do. And please, if you disagree, just step in and let me know. Because I'm also new to the whole system, right? So the main idea is that for continuous vulnerability scanning, we want to provide a way to GitLab to have all the knowledge about all the advisories that exist. So we have multiple sources of advisories. For instance, for dependency scanning, we have GymnasiumDB. For continuous scanning, we have TriviDB. And the idea is that we want to ingest those advisories, process those advisories, and in the end, we want to store them somewhere externally, like a bucket, where the GitLab instance will basically pull that data, store it in the database, in the GitLab database, so that it can basically do continuous vulnerability scanning. In this first iteration, we work mainly with GymnasiumDB. So we were also thinking about what we need to do about TriviDB and continuous scanning, but our main scope and focus is basically on dependency scanning and more specifically on GymnasiumDB. So we basically start with just one advisory source. And we are basically working on this diamond shape here on the ingestion. How are we going to ingest that and export it into a bucket so that GitLab can basically fetch that information? So this is more or less the overall design. So you will see I have something like a block diagram, and I have different colors depending on what we are talking about. So with orange, I'm talking about a GitLab job, right? So basically binary that can be executed by a GitLab job, and by blue is basically something that runs on GCP or a GCP resource. So the main idea is the following. So the first component is the advisory feeder. The advisory feeder works more or less the same way the license feeder works, in the sense that it gets triggered by a schedule. So we can execute this job once per day or multiple times per day, doesn't really matter. And what it will do is that it's going to clone the GymnasiumDB. I'm talking about GymnasiumDB because that's the scope right now. It's going to fetch information from a GCP cloud storage bucket. And the information that we store there is the last commit that we have processed the last time, so that we don't need to start from the beginning. We can just see the differences between the last process commit and the latest process and the latest commit. We will find all the updated or newly inserted advisories. We are going to publish them on a PubSub topic. Now, that PubSub topic will send those advisories to the advisory processor. And the advisory processor, most probably, it's going to be also similar to the license processor. So it's going to be a service that is going to run on Cloud Run. So that's running on GCP. It will work as a server in the sense that we are going to use most probably PubSub push. That means that every message received on a PubSub topic, it's going to be forwarded as an HTTP API call on the advisory processor. And the advisory processor is going to get the information about this new advisory, and it's going to store it in the right format in the license DB. And our license DB is basically the same license DB that we are using for the whole license ingestion pipeline. So that's running on Cloud SQL, which is basically the GCP version of an SQL database, a managed service, basically. And then the final component is the advisory exporter. This is also triggered based on a schedule. So it's up to us. And that component will work more or less the same way as the license exporter component. It will get the information about the advisories from the license DB, and it's going to extract them in new delimiter JSON format into a cloud storage bucket, which will be public. And that public bucket can be used then by offline GitLab instances, or in general, any GitLab instance, to fetch that file and ingest all those advisories. On the next slide, it's more or less the same design, but in this format at least, right? I don't want to get into too many details, but again, you see that we have an advisory processor which runs on Cloud Run. This is fed by a PubSub topic, which is again fed by the schedule advisory feeder. So you might be familiar with this kind of drawings from the deployment project documentation. And this is just an update, but for advisories right now. Okay, so let's focus now on the advisory feeder, because I think that some of the efforts that we did during this iteration was also focused on the advisory feeder. And this is also what I would like to demo. So advisory feeder, basically, it's a CLI command tool, right? It runs exactly the same way as we do for license feeder. So that means that we have some run configurations where we can pass some options like log levels, or which internal bucket we want to talk to, or the PubSub topic. So very similar run configurations as the license feeder. And of course, this is normal because, as I mentioned, the advisory feeder shares exactly the same code repo as the license feeder. And what we do then is that we have exactly like we do for Gymnasium, where we have in the command folder, we have two different mains, depending if we want Gymnasium Maven or Gymnasium Python or just Gymnasium. Exactly the same way we can differentiate between advisory feeder and license feeder. But this is very nice because we can actually reuse a lot of components from the license feeder project. So what it actually does is that first it clones the Gymnasium DB Git repo. This can be easily extended to work with any Git repo. So that's the nice part. Once we clone it, we read the cursor. And in the cursor, as I mentioned, is the last commit hash that we have processed. Then we compare and we find the advisories that change between the cursor commit hash and the latest master. And those advisories, we publish them directly on the PubSub topic. And then, as a final step, we store the latest processed hash commit back to the cursor. So the next time the advisory feeder will execute, it can continue from where it finished the previous time. In this first iteration, we just focus on dependency scanning. So we try not to think about the data structure that we might need for container scanning and TriviDB, because there are some differences, but I'm going to talk about this in a bit. So the data that we basically send to the to the advisory processor, so this should be processor here, contain two main things. One is the UUID that we extracted from inside the advisory, and the JSON advisory, so the raw data. And we use exactly the same schema as the one used by the Gymnasium DB repo. So these are the two only things that we send, and that's because we want, in the license DB, in the end, we are going to store the JSON the JSON advisory, and the UUID is basically the identifier that we need in order to do upserts. And yeah, as I mentioned before, also advisory feeder can be executed once per day, and it's quite fast, especially when it doesn't need to start from scratch. So you will see also in the demo that it's quite fast. Yeah, when it comes to the database schema, we discussed a lot about this. This is the current schema that we have. So we have a GitLab advisories table, and in there we just have the UUID, the raw advisor, which is in JSON-B format. So in case you don't know this format, PostgreSQL allows you to store a JSON object, and it has the JSON format and JSON-B format. There is a small difference there in the sense that JSON-B basically stores the binary data, so it does some kind of encoding, and the insert, it's a bit more costly, but in the end of the day, you can actually access the data inside the JSON object, so it's very nice. And of course, we also have a last updated timestamp. Now, the interesting thing is that for container scanning, 3VDB stores the affected versions and the advisory in two different tables, right? So but in GymnasiumDB, we just have one object that has the advisory details and also the affected version. So that was a big change. Eventually, in later iterations, probably we should adapt the advisories so that also for GymnasiumDB that we extract this an advisory item and the affected versions and store them in two different tables. But this will come in the future. Yeah. So I'm not going to get into too many details here, but I'm more than open to discuss this because there are many details here that I'm going past them a bit fast during given the time that we have. A bit about the current status, which I think it's interesting. So a lot of work has been done about the overall design and keeping in mind actions that we will need to do for continuous container scanning. And yes, special thanks to Fabian and Igor for their significant efforts there. They are both very knowledgeable, especially for parts of the system that I have no clue, like the GitLab instance word and the database there. I haven't worked there, so it's really nice that Fabian and Igor they can do some really nice work on that side and give me a lot of interesting information that I didn't know about. So the schema DB work, it's actually complete. All the infrastructure needed and required by the advisory feeder is actually complete. When it comes to the advisory feeder code, is actually in review right now as we speak. We expect this to finish in the first week of 16.0, and that's my own estimation. So don't take my word for granted, or in the end of 15.11, depends how fast we go there. Advisory processor, this is the next big thing to do. We have started refining it. I'm currently trying to understand how easy it is to reuse the same code base. Hopefully we can do that. And advisory exporter, nothing there yet. We need to refine this, although most of the information it's already known, so probably it should be relatively easy to refine it, and we could actually start working on advisory exporter in parallel with advisory processor, right? And that's it. I'm gonna go to the demo, but please ask me things because I'm not sure if the fact that you're not saying anything is
yeah
so.
it's difficult when you don't get any feedback. You're not sure if people are just not listening or if they have no question at all. So usually you can have, if you want, the agenda doc on a side screen or quickly accessible, because what people can do is write questions in the doc as the conversation goes. Depending on the presenter, you might like to just not be interrupted, or you might welcome interruptions as you're making the presentation. I mean, both approaches are fine. But yeah, there are a few questions there. So maybe we can discuss that before going into the demo.
Yeah. Would you like anyone that has a question? Can you?
Yeah, I'll
maybe...
go ahead and verbalize that.
Yeah.
The first one, a few just more commentaries, just for everyone to be aware. GymnasiumDB is also known as GitLab Advisory DB. GymnasiumDB used to be the old name. This is still the name of the repository, but it might be mentioned as GitLab Advisory DB in other places. Also, I think something that we haven't yet discussed, but maybe as a follow-up post MVC, it might be good to have some checks to verify from time to time that we're still in sync with the sources. Like this is something that we've seen being useful for continuous scanning, for instance, when we are building and importing the TriviDB. We have a check that runs internally that check the database is not outdated for more than 48 hours, for instance. I don't know if there's something we could do also in our GCP setup so that we can check regularly. I don't know, do a full clone, check how many advisories we have, and check how many advisories we have in the database, and make sure that we're not having a bug that makes us missing some data. I think that would be useful. I don't know if this is something that has already been discussed so far.
As far as I know, we haven't discussed that, but it's something that we could do quite easily, to be honest, I think.
Cool. Added to do for a follow-up issue then. Next one, you said the advisory feeder execution is really fast, and so far it's planned to run it once per day. I think it might be useful to raise that frequency to reduce as much as possible the delay between the advisory is disclosed, it get ingested into the Gymnasium database, and then we sync the Gymnasium database with the advisory feeder store there in the license DB, external DB, and then we sync that with the raise model. So there are a lot of intermediary steps that can make this end-to-end process take much more time than expected. So if we can run that more often and reduce this time, that would be great.
Indeed,
so
you're right. You're right, and maybe it's my mistake. When I said there once per day, it's just a number there, right? It's not that we have discussed, and I would also expect that we can run this even once per hour if we want to. I really would like to see that running in a job, because currently I'm running everything from my laptop, which of course is going to be much faster than a Docker container, but I'm pretty sure it's not going to take much more time. So it's not going to be like 2 hours or 3 hours like we see with some of the license feeder jobs, right? So I think it should be relatively fast.
Cool, awesome, thank you. Next one is read-only, some feedback on the presentation that you can look after the presentation, but I'll cede the floor to Sarah.
Thanks. Could we just go back to slide 2? I can see it.
Yes.
Thanks. That's the one I guess I have a question about. I just saw the Postgres database at the end, and with the license compliance feature that has been rolled out, like we're having to raise the requirements for installation basically. And so I was just curious if this design would also lead to the same issue.
So if I understand Sarah correctly, the question is that you're talking about that issue that we had with the license ingestion, where we were having a bucket here, a CSV bucket with licenses, and that had to be ingested, and it was too big, right?
Yeah.
Yes. So I think Igor was the one that pointed that out, right? I think the Gymnasium DB or the GitLab Advisory DB, it's relatively small. I think something in megabytes. Please, Igor, correct me if I'm wrong. And TriviDB, it's going to be for the first iteration where we will have everything in one table. It's going to be 3 gigabytes.
Okay, thank you.
Igor, did I say that correctly about the numbers?
Yeah. The GitLab advisory DB is only 20 megs. The Privy DB, depending on how you design the output format, like on disk, it's 340 megs. So definitely can fit into memory, but I think it depends on how we decide to, like, what kind of duplication exists in the format.
Exactly. So just to give a bit of more information on this, Sarah, if we first take the TriviDB, which stores the affected versions and the advisories in two different tables, if we want to make one big table out of it, then we will create some duplication, and that will increase the size, right? That's why ideally at some point we would like to have two different tables also for GymnasiumDB. But okay, given the time, because we are already on time, let me make a very quick demo. I hope that's okay. And if you have more questions, I will answer those later, async. So right now, this is the license feeder project. I'm just going to run it directly from the source code. It's like running it from main. Maybe one thing I should actually show you is I'm going to run this into my own personal GCP project. I have a cursor. The cursor is on a commit not from the beginning, so there is a value there close to the latest commit hash. I think it's from yesterday or 2 to 3 days ago, so we should have some new advisories. One more thing that I wanted to show you is that we have a topic for Dev Advisory Processor, and I would also like to create a subscription. Let's name this test, so that you can actually see the data already exists. Test one, maybe. So this will take a second or two. Okay, we can go here. You see there are no messages, of course, yet. And what we can do is we can actually run this. I'm not going to run it on dry run. I'm just directly going to run it, and I'm going to send all the messages on the PubSub topic. So I'm going to do that. And yeah, right now it's cloning the GymnasiumDB repo, as you can see here. And then it read the cursor, it fetches the latest commit hash, it compares those two, it sees that there is actually a difference between those two. It found 91 new advisories that have been added or updated, and then it published those data. So now if I go here and pull this, I should see the data. So what you basically see is the UUID and the raw advisory, which basically are JSON bytes. So not very interesting to see, but you see that here we have a bunch of messages, and there are more.
Do you have the 91 there?
Sorry?
Do you have the 91?
That's a good question. Not sure how to see that. Probably, maybe, yeah.
Oh, that's
probably
not important.
Yeah, but there are 91. You will need to trust me on this. If we wait a bit, most probably we will have some metrics here, and I think they should come. Yeah, I think we need to acknowledge those messages, and probably more of them will come once we acknowledge them. So yes, so you see there are more and more, and the more you acknowledge, the more messages you're able to see here. So yeah, this is not the nicest way to see, but you see that there are more than 30 messages. So according to this, there are only 20, but in reality, there are more, right? So maybe next time I can also create another application that actually prints the whole number and receives all the messages. But yeah, until then, that's it.
Awesome. Thank you very much.
Yeah.
That was very helpful. Particularly the diagrams, I think, are very easy to visualize the architecture. Thank you also for making the comparison with the license architecture too. I think that's very helpful. Great work. Keep going. Sounds like there is a lot left, but so far that's cool. Thank you very much for the presentation.
Okay, thank you.